Okay, so the one more thing is scalar multiplication. Okay, and I have to use this word scalar. Think about a scalar as a regular old number, right? Vectors have a couple of numbers in them. Scalars are just regular numbers. Like integers are an example. So let's say I had 2, and I wanted to multiply 2 by my favorite vector 1, 2. I really should name this thing. Okay, so if I want to do 2 of 1, 2, how would you think about this? What's your first thought? When you multiply something by 2, what are you really doing?
Doubling everything.
You're doubling it, you're adding it to itself, right? So this should be, if there was any justice in the world at all, this should be 1, 2 plus 1, 2. Thankfully, there is in fact justice in vectors. There is not in cosines and sines, but there is in vectors.
Okay.
Okay, so you just do this. So we go over 1, up 2, there's my vector, and then from there,
Over 1, up 2.
over 1, up 2. You guys see I just took the vector I had and doubled its length? Okay, so when I want to do, I don't know, some scalar t times some vector v, right? What do you do?
Make them longer.
Yeah, this is a vector with the same direction, and I'm writing same here, but that is a little caveat on that. Same direction, but t times longer. You guys with me on that? I just adjust the magnitude by a factor of t. I said that I lied to you a little bit in the middle of that.
Yeah.
I said you should be concerned about this. Why should you be concerned about that?
Because it doesn't serve the origin every time.
No. It's not always going to be the same direction because sometimes t could be
Negative.
negative, in which case it would be the
Opposite direction.
opposite direction. You guys see that? If you think about this as literally the same direction, but maybe allow negative times longer, and just interpret that as pointed in the opposite direction, this will still work. You see that? So this same is as long as you're thinking the right way about negatives with this. You guys okay with that? You want to see an example?
Yeah.
Okay. What if I did negative 2 times 1 comma 2?
We'll just go that way. 2. Negative 2.
Should be this, like this vector, right? But then negative twice as long. So twice as long is this vector, this black one. And negative means it points the other opposite way. So here's your result.
Okay.
You guys all good with that?
So it wouldn't start at 1, 2. It would automatically just go straight down from wherever it started.
Yeah.
Okay.
So you could think about this as do this bit, right? Hit the black one, then flip it over.
So would that be negative 1, 2 minus 1, 2, or would that be 1, 2 minus 1, 2? Would you start with that?
Be like the first one's negative, the second one is just mine.
I think this is a valid interpretation. It might be better to interpret this as plus minus.
Yeah.
Minus being just the vector that looks like 1, 2, but pointed in the other direction. Cool? Questions? Steals? If you wanted coordinates for this thing, what do you do? Negative 2, comma,
Negative 4.
negative 4. Yeah, exactly the same thing, right? Take this, distribute onto the pieces. Why are you distributing? Close. How about think about this thing as a 1i plus 2j. You're multiplying by 2. You need to distribute across that addition. Cool with that? All right, let's practice some of these.